We are in Precalculus on this beautiful Wednesday, November 14th. We're on lesson 3-2, magnitude. Let's go ahead and put the date on here while we're at it. Today was November 14th. So, some vocabulary and some notation. So, initial point. Initial point, what's another way of saying initial?
Start.
Yeah, start. What's another way of saying terminal? The end. The end value. Yep. So magnitude. Do you remember that from last lesson, Daisy?
Length.
Yeah, there it is, length.
Oh.
And there's notation for how to do magnitude. So if I want to find the magnitude of, let's say, vector A, so this is vector A. It has an arrow above it, yeah? Magnitude is chunk, 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 chunk. It's like double absolute value. That means magnitude.
So if it was a negative, and it was inside of those two lines, then it would be positive. But if it's in another line, is it negative or positive?
It's always going to be positive because you can never have a negative length, right?
So why have two?
Because it means magnitude. It just means, like, if I read this, I say the magnitude of A. In fact, I'll write that here. This means right here, and you'll write it down with me, the magnitude
Does it mean
of vector A.
So it's only for the x-axis or for the y-axis?
It doesn't mean X or Y, it just means how long it is. And I'll show you an example of that in example 1. So it's asking for length. And length is always positive. We can always write that down here. Length, GTH, is always positive. Which makes sense, right? It's because the notation matches what we inherently think. It looks like absolute value. Oh, it's always positive. So kind of like absolute value. All right, so I want to find the exact magnitude of U. I want to find these double bars around U. How long is U? And we touched on this yesterday, but now it's formally going over it. I'm going to make what? I'm going to draw 2 lines to make a
Triangle?
triangle. Do you know where I'm going to draw my lines?
Probably on -5 and 3. I mean, like at -5 and -2.
Okay, there's a dot. Yeah.
And at 3 and -7.
3, -7. That's like down here somewhere.
Sorry. -7, 3.
-7, 3. So like that.
Wait. Can you repeat that? I don't know what.
Hold on. Let me just show us the right way of doing this. This is my triangle.
Oh. I'll make it an actual triangle.
Oh, yeah, you don't need to make an actual triangle. We're just making a triangle to help us find the length. Because we're going to be using whose theorem?
Pythagorean theorem.
The Pythagorean theorem. Named after that guy, Pythagoras. Do you guys know anything about Pythagoras, by the way?
Nope. Can you tell us something about it?
He was like a cult leader.
A what? Cult?
Yeah, it was kind of a cool thing.
Wait, show us.
Show us? I mean, it was like in the time of the Greeks, so there's not like pictures or photos or anything. There's probably drawings. Should we see a picture of Pythagoras?
Yeah. Did you do that when we filmed both of our guides, whatever they're called?
Pythagoras. Pythagoras. This should have a picture here in Wikipedia.
No, Wikipedia. Born.
Just a. That's an interesting reaction. Yeah. I hope I'm not misinforming you, but I'm pretty sure he was the leader of a cult, and that cult would literally kill people if you said that square roots and weird things like that exist.
So it's like the chocolate cake?
No, it's
What?
not that bad. It's not
No.
racist.
What I mean, not racist. I mean the fact that it's like they kill people just because of their own beliefs.
Yeah, they kill people because of their beliefs, for sure. So if you said square root of 2 exists, they'd be like, no, come out here to this ocean in the middle of the ocean, and oh, he's gone. Oh no, he died, maybe. Don't know what happened to him. He's just missing. You can't believe in square root numbers. Those don't exist. Those are irrational. We only believe in rationals. Anyway, that's my...
So that wasn't rational?
Square root of 2 is an irrational because it has a square root. They didn't believe in square roots. So, yeah, I hope I'm saying that right because it's been a while since I've done my math history. Anyway, this length in the x direction is how long? Is it positive or negative? Number, tell me. Rochelle, stop looking at your phone.
What do you want?
I want this length.
What? So it's gonna be 2.
2. And this length here is going to be
5.
5. And we're going to use Pythagoras, that guy, that Pythagorean theorem, named after him.
C equals square root of 29.
You're already there. So let's go ahead and set up really quick. So here is my 2. There is my 5. And I'm going to write the rest of the Pythagorean theorem around this. So I'm going to square that leg. Square that leg. It should be equal to that hypotenuse that we're looking for. I'm going to call that u squared, because this is the length of u. So this is going to be 4 plus 25 is equal to u squared. And Rochelle gave us, I'm not even on Rochelle's step yet, this is 29 is equal to u squared. Rochelle gave us that u is equal to the square root of 29. Can it be, it should be positive or negative, right? Because whenever you take a square root, you do positive or negative.
It should be positive because it's going up.
That, you're correct that it's positive, but your rationale, your reasoning is not correct. Here's your rationale, right here.
You're so mean to him.
Dude, I'm not feeling right now.
Here's your rationale. Read it off.
Told you. Length is always positive.
Yeah, length is always positive.
You don't let me finish, man.
So it's positive. Positive square root of 29. There is your answer. And again, I don't think Khan Academy nor Mr. Sindel care about whether or not you're able to reduce radicals, because I assume that you know how to do that. Can you reduce square root of 29, for example?
What?
Can you reduce square root of 29 into something else?
Yes, you can.
What can you reduce it down to?
What you can do is you can find 2 numbers that multiply 29.
Yep, I can find 2 numbers that multiply to 29. You ready?
Yeah.
1 and 29.
There you go.
Okay, then what?
Yeah.
Then you're done? So square root of 29 cannot be reduced. It's just square root of 29. There's our answer. Box it. Square root of 29. Positive version. Square root of 29.
So it will never be a negative.
It will never be a negative.
Okay.
Ever, ever, ever.
So Khan Academy won't pull that stuff on us.
Nope.
If it does, I swear.
Because we're talking about lengths, and lengths are always positive. I mean, you can have a negative vector, but if you're looking for the magnitude, magnitude is length, and length is always positive. So magnitude will always be positive.
So instead of the vector, it's gonna be, it can be negative.
The vector can be negative because it can have a negative direction, I guess, depending on your orientation. But yeah, so vectors can be negative depending on your perspective, but magnitudes are always positive. Vector u, it has an initial point, a start. We'll go ahead and write start above this in case we forgot. It has a start point at -2, 3, and a terminal point, or an end point, at -5, -1. I need to find the exact magnitude. By saying exact, they say don't, well, I mean, on Khan Academy, you can use decimals. Just do square roots, because I expect you to use square roots. So, what am I going to do?
Fine. So now it's gonna
Let's talk about how far, let's do a length in the x direction. It's always going to be positive because I'm not asking about length. I don't care about negatives. How far have I gone between -2 and -5? There it is. Daisy, say it louder.
3.
3. And Rochelle, how far have I gone in the y direction? I've gone from 3 to -1.
So it's the square root of 20.
We'll get there. I don't know if it is. I think it's not square root of 20. I think it's square root of 25, which is 5.
Ooh.
But it's cool that you're able to do
That-
mental math. Well, let's see, right? So how far do I have to go from 3 to -1? What is the distance?
Oh yeah, you're right. It's 5.
How far do I go? What is the length between 3 and -1?
4.
4. All right, so here it goes. Let's do super fast Pythagorean theorem. There's my 3, there's my 4. Write Pythagorean theorem around it. That thing squared plus that thing squared is equal to the thing that we're looking for, u squared. So that's going to be 9 plus 16 is equal to u squared. From there, we know that's going to be 25. 25 is equal to u squared, and from there we know we take the square root of both sides. So you get the square root of 25, which is plus or minus 5, but it's always positive because it's always a distance. 5 is our distance. Did I box my answer? I did. Square root of 29. Questions? Questions, questions, questions. Get your questions here. All right. Example 3, and I think we're going to be done after that. Yep. Okay. This is vector u, and I know that yesterday I told us that you can represent vectors by having these little less than, greater than kind of signs to make it a vector. And that is how you always see it in college, but I don't know why Khan Academy does parentheses. It's just another way of notating it. It is preference, and Khan Academy's preference is using parentheses. So Khan Academy will say vector u is 2, 8. So I need to find the exact magnitude of u. It told us what our legs are. Our one leg is 2, one leg is 8. We just plug those in straight away to Pythagorean Theorem. So you guys are going to walk me through it. Tell me what to write for Pythagorean Theorem. I know that you want to do it in your head, Rochelle. Tell me what to write, though.
Okay.
There's my 2, there's my 8. What am I going to write?
Equals u squared.
Equals u squared.
So 2 squared plus a squared equals u squared. So it's 4 plus 64. So it's square root of 68 equals u.
So 68 equals u squared. U is equal to the square root of 68. And square root of 68, can that be factored down further? Let's see, that's going to be 28. It can be factored down further. And you don't have to do this, but let's just go ahead and do it since we finished this lesson super early. Square root of 68, let's reduce it. Get a little bit of a review in here. What are the factors of 68? Let's do a little number tree. Old-fashioned number tree. 68, what and what? What times what is 68? I know 2 because that's an even number. 2 and 34.
Oh, wait, really?
Yep. 34 is what and what, Daisy? Or Rochelle? I know 2 is one of them because that's an even number, so.
So it'd be 17.
2 and 17. 17 is what and what? Nothing. It's a prime number. So circle your prime numbers. Ready? Circle, circle, circle. Those are our prime numbers. If you see a pair, you write it on the outside. If you see a single number, write it on the inside of the square root. So this is going to be 2 on the outside because there was a pair. And on the inside, there's only 117. This reduces to 2 radical 17.
Is that what Khan Academy wants as well?
Nope. Khan Academy wants square root of 68.
Because it's kind of like the square root of 4 times 17, and you can separate them.
Exactly, yeah. This is really, so the square root of 68 is really the square root of 4 times the square root of 17. That's where this thing came from. This is our shortcutting method of doing it. And square root of 4, of course, was that too. Any questions on today's lesson? All right, that concludes the lesson.